So remind me when we get close to that. Okay. So first thing I'd like to do is, at the end of last week, I kind of talked about how I would like to do a few more things because we didn't quite get as far as I wanted to. The first thing that I did was I modified this assignment a little bit because I think it was unclear, and I actually made it not quite as difficult. And so the main difference here is that for the script that we worked on last week, what the output needs to be is just the circles that represent the smallest circumscribing circle. So we did that all together in class. We got that far. So that's the output. But in one of the columns, you do need the ratio of the area of the city, the original city, to the area of that circle. So once you get that, you'll be good. You no longer need to like clip the two areas and provide an output. Okay? So the area of the output polygons is going to be that circle. So I can show you where we kind of left that. Here, well here, I don't need to do that because I have that right here on. Okay, so basically this row 6 just needs to be, well, this comment, we don't need to add anything. That new, oh wait, yeah. So we no longer need, will you buffer that? Yeah, we don't clip it anymore. Okay, so that's right. We don't need to change this polygon at all. That new polygon is right. So this line is good the way it is below. All right? So originally I was saying that needed to be clipped with the city area. The problem is that for some reason those cities didn't all work. Like some of them would cause errors, so some people were getting errors. I figured one thing that we could do is just report all the errors like we've been practicing, but this will make it the assignment a little bit easier. So we're just going to output this circle. This represents, what does this circle represent, by the way? That circle that it creates, we called it something. It's the smallest circumscribing circle. All right? So I think there's still a few issues to work out for some of you because I noticed that sometimes they weren't the right circles. And the other thing about this assignment is we'll make it due in a week from today. That's that assignment. So this is pretty much done because we even did the area ratio already too in this script. So that's pretty much done. Now we didn't get very far in the second assignment though, right? This is the what's that? Animals, yes, animals. All right, the second assignment we didn't get very far. In fact, I don't think we got very far at all, but I told you there's an example already up there. But and I kind of walked through the steps on that assignment. So we could flesh that one out a little bit more before we get into this week, if you like. Yeah, I think that's probably good. All right, so what I was saying with that assignment is that you need to have two cursors. One cursor needs to read through the existing file. What type of cursor should that be? Search, insert, or update? We're just going to read. Search, exactly. The search cursor is an equivalent to read. It means that we're just getting the information out of it. The other cursor needs to write to a new file the line work. So what kind of search cursor, insert, or update? So update was what we did last time with so that one was where we replaced values in a file. So update allows us to replace the values in the file. We don't even have a line file yet. So we actually need to go with insert. So insert allows us to put new rows in. Update allows us to change the values in the rows. Does that make sense that that's the difference? Search just lets us read. Really, search and update aren't too much different. We could use an update cursor in all cases where we could use a search cursor. There's really no reason for a search cursor other than if you want to make sure that you're never changing the data. Okay? So you use a search cursor and an update cursor the same way, except for an update cursor allows you to change the data. So if you want to read and change, it's update. If you want to put new rows in your table, it's insert. Okay? So we need one search cursor to read through the existing points and one update cursor to change, one insert cursor to create a new table because we don't have one. All right, so let's do that. So I'm just going to go to, I got too many tabs open here. ArcGIS, or ArcMap, insert, cursor. I'm going to just borrow the code from help. So here is some code from the help. Oh, I said insert cursor. Oops. I do need an insert cursor, but we'll get to that in a second. So I'm going to change this to search cursor. So I'm going to read through the existing point shapefile. Okay, so here's a little snippet, code snippet that helps you get started. So here's our insert cursor. We need to change this because we don't want that feature class. Okay, this is actually the older version. Sorry. This is the older version that doesn't use DA. So let's get the newer version. The data access model. All right. So here's a good example using the data access model. Okay. So we need to change the feature class that we're going to use, and we need to change the fields that we want, and then we're just for now let's just output and show that we actually are going to go through each and every line in the program. Do I even have this data downloaded? I probably do. CSPA lab week 8. Yes, GPS points. So if I go all the way in and I hit preview, I can see those GPS points right here. And I can actually copy the path. I know that's really not detailed, but I'm clipping up in the upper left to copy the entire path down. And I'll put an R in front of it. And we need to get two fields out of here. There's animal and time. Those are the only fields that we need, except for the shape itself. We don't need the FID, and there's not any others. So let's do. We do want the point. Let's just say shape at though, and then we'll get the time and the animal. So the way that I want you to read this is that time. These are just numbers, but they represent the higher numbers are earlier in time. Are later in time than the earlier numbers. All right. So now we can just run this, and we'll get those values printed out. I'm gonna go ahead and save this as C temp SPA and this is lab 9. I'm going to call this lab 9 2. This is the second assignment. So let's see if this works. Should work. So the last item is going to be just this is just the geometry, the point. So we got 30, 4, 2. So we're getting all the numbers. Now, I mentioned that it would be ideal to sort these values instead of giving them to you, because we've got 6, 9, 8, and then also by time. We really need to sort them by animal and then by time. Okay. Now, I've mentioned this, but maybe this didn't appear or you didn't think about this before, but we do have the ability to actually enter a SQL clause. One SQL clause we can do is say order by. So if we go like this, which parameter is that? That's after field names. We've got 1, 2, 3, 4. So something like this. 1, 2, 3, and then the SQL clause, default value is none. So let's put none there. None. Sometimes the default value is nothing, and sometimes it's none. None, none. And then finally is the where clause. So we can say order by, and then give it a field name like animal. And then we could give it another field name like time. So now it's going to sort that column by animal and then by time. So when it runs again, SQL calls a sequence of 2 strings. None. It says order by. Oh, that's the problem. Okay. This isn't going to work either. The problem is that it's not supported when we're working with shapefiles. Okay. Here, I'll show you the. Where's that?
Like for the 2 sequences, you did like 9 and then your clause.
Yeah, that's a good idea. So you're saying look at my previous year? Because I had it working. Archive. Which one is it? 7.1? Yeah. Okay, say what you were saying before.
So instead of just the clause, it needed like a prefix and needed like 2, like if you go back to the help thing.
Back to the help. There. Oh. Too many. Okay, here we go. Yeah, the help. Yeah.
It says that there is the prefix, you need to either put 9 just over the top, and then do a comma and then the where clause.
Oh, so it's a tuple now. Okay. But
Dr. Rick,
yeah.
can you sit on that code for just a second so I can get caught up?
Sure. There's no there's no post fix like that. There we go. I'm back.
GPS point, is that the SEC?
No, the GPS points is the point shape file. It's on there. It's in the yeah.
What's at the end of the order by animal?
Okay, so
What's at the end of that? Yeah, there you go.
it looks like that. Okay. Yeah. All right. Now it actually ignored this part. Okay. But we got the syntax right. It's a newer. The newer syntax is having a prefix and a postfix. So, but when I actually ran this, it didn't actually change the data. See how it's 1, 3, 2. It didn't sort it. Okay. If I wanted to actually sort it, what I would have to do is I can do this fast enough. So if you guys want to follow along, then you'd have this data. So I created a new data set called tracks, and I created a new feature data. I created a new geodatabase. How did I do that? I said new file geodatabase, and I called it tracks. And inside file geodatabase, I'm going to import the GPS points into that file geodatabase. So all I'm going to do is right click and say import, choose the GPS points. Okay? And then hit OK. I'm basically just copying, I'm going to call this GPS points. I'm basically just copying the GPS points into another format. They were a shapefile, and I'm making them tracks. I'm putting them in here, so now they're in here. And they look exactly the same, and they have the exact same fields, except for they're in a geodatabase now. So if I copy that new file and run it, okay, look here. See how these guys, they're not sorted? But if I run it here, now that it is a file geodatabase, they will be sorted. First by animal, then by time. An invalid SQL statement. Let's try sorting it just by animal and see if it doesn't like that. Yeah, that worked. Okay, see how they were sorted? 5, 6, 8, 9. Well, the only thing I forgot to do was put that comma in. So now it's going to sort it by this and this. See, now all these are sorted, and then all these are sorted. All right, I'm going to go back to the code and hold it there for a second. So if you want to try to copy the code here, I'll put this up there, but there's the code. I'm going to say one more thing. All that stuff that I just did, rearranging the data, saving it, is actually not necessary for this lab, because even though the animals are out of order, they're already still sorted by time. So and they're grouped. So you'll still get the exact same thing. You'll just get the line will be the 5th line instead of the 6th line, doing it this way. But the lines will still all be in there, and they'll still be in the exact same order. But this information is really good to know in case your data was collected or was put into the database in a different order. It's nice to be able to know how to sort your data sets, okay? And so, oh no. Oh, there. One thing that's important to remember when I did it in a shapefile, it actually didn't cause any errors, but it didn't sort the data. So unless it's in a geodatabase, it actually won't sort your data for you. Okay, so that's why I took those GPS points and put them in a geodatabase so it'll sort the data. But even if you work on the original shapefile, you'll be fine. For this lab, you don't actually have to have that order by statement in there. I'm just showing you how to do it because the data itself is already sorted by animal kind. It's grouped by animal and sorted by time. Right? So you technically don't need to do that. See how 4 is after 5, but it's still sorted by time. 25, 26, 27, 28. So you'll be fine. Another option is, if it was easy, you could bring this into ArcGIS, sort it by what you wanted to sort it by, and export the table, and it will be in the right order. So if you only needed to do it once, you could do that. Okay. But this is good. It's good to be able to sort your data. There are cases where it becomes important.
Sorry, what did you say the output feature class was, or name it in the...
I just called it GPS points again.
It's on, okay.
So now we've done the entire reading it in. So now I'm just going to put in the code, because what we need to do is every time the animal changes, we need to be storing we need to be constantly storing the path that the animal is taking. So we're building a new polyline each time the path is created. And every time we get to a new animal, we can save out the old animal into the polyline shapefile. All right, so something like this. So one thing that we need to do is find out what the first animal is. Okay, so I'm going to have a few initial variables set up. I'm going to set up some variables. One's going to be the initial animal, and for now I'm just going to set this equal to -1. And because I know none of the animals are -1s. Okay. Then I'm also going to create so do I need any more? I don't think I need any more variables for now. I may need one in the future, but I don't know. Okay, so I'm just going to say an if statement. If I animal is equal to -1, then which one's animal? Is it 0, 1, or 2? It's 1, yeah. So I'll say I animal is equal to row 1. Then I could say else, and then I could yeah. No, I don't even need an else. So what needs to happen here is that if it's equal to -1, that means that we're encountering the very first record, because it's only going to ever equal -1 here. So now it's going to be I animal is going to be equal to row 1. So every time through the loop, we need to make sure that we're still on I animal. If we're not, if we're on in the next animal, then we need to do our thing. So now we need another if statement. If I animal is equal to row 1, actually, I should say not equal to, I think, because if they're equal to each other, we need to do something in either case. Actually, yeah, let's just say equals. Start with equals. I'm just going to put, for now, store the point for the path, yeah. And then say else. Actually, it's not going to be else. Yeah, it will be. But we want to actually store the path the whole time. So we don't need to do this. It's only going to be not equal to. If it's not equal to the next row, yeah. I'm getting a little bit. The logic is I have to think about it for a second, right? Because let's go back here. So what I'm trying to say is, we get a value of 1, then a value of 1, then a value of 1, then a value of 1. We're just connecting the dots for all of these. But what if we get to 3? What do we need to do once we get to 3? That's where we need to cut off and say all of these are one path, all of these are one path, all of these are one path. So whenever we encounter a new animal, we need to lift up our pen, basically. All right, so if we go back over to here, if it's not equal, we need to lift up our pen, okay? And part of lifting up our pen will be that we create a new animal and save the old animal. We'll do both of those things. So we'll save out the current path, and the current path meaning the current animal path, I'll say that, so it doesn't sound like it's a file path. So we're going to save out the current animal path, and we're going to create a new polyline to store the new path. And then actually outside this loop, outside this if statement, we'll need to store the current point in the current polyline. So that gets done no matter what. But which animal it gets stored in is dependent on whether or not we've incremented to a new animal. So those are the 3 things that we need to do. All right. So we actually also need to do this here because it hasn't been done before. So see this, create a new polyline to store the new path? That needs to be done up there. So we could put this right here. Sounds like we're doing the exact same thing twice. We're also doing this really however many animals there are. These both seem like very good candidates for a function, for a new function to work. Let's review. Let's look back in the help. Arc I right polyline. Let's look and see. So the way to create a new, so here's an insert cursor. The way to create a new polyline is to actually feed it an array of points. We're going to be getting points already. So what we need to do, what data type is this? What this bracket indicates? A list. So really, we just need to be creating a list. We need to be creating a list and destroying the list at certain times, or emptying the list. Whatever thing we want. We only really need to do this when we're actually going to get the new polyline, so it's an array. So let's do something like this. We'll call this up at the top here. I'm going to say def what's that? Yeah, well, I was thinking of the one that's going to create the new polyline first. New list. And we're going to feed it, actually I don't think we need to feed that anything, because it's going to create a new polyline to store the new path in. Yeah.
And what that would be is inside the list, each one of those, so for example, animal 1 has 1, 1, 1, 1, that would be inside the list.
Yeah, well, each time through it's going to get the value of row bracket 2, the point. So that list is just going to grow. You know what? This function is only going to have 2 lines of code in it, because all it needs to do is empty the list. Okay? So I don't know that needs to be a function. The second one probably will work well as a function, but I think the second one will work well just as a like this. So we just set this up as a variable outside the loop, and then every time this needs to be emptied, we just empty it. Okay. So we don't actually no longer need to do this because it's initialized already. So this one's gone. So this one, where we create a new polyline to store the new path, that's just emptying. This is just going to be empty the list. Okay, so we could just do that by doing this. So the current list of points just gets, in fact, it's only 1 line of code now. So every time we get to a new animal, we save out the current animal, we empty the points so that the next time through we're all set. Okay? So saving out the current animal does seem like a good candidate for a function. Of course, it's all compartmentalized in the same part of code, but it might still be kind of cool to write as a function. Def save animal. Okay, and it's going to take the list of points. Let's just call it LOP. No, LOP. No, not. Yeah. Just LOP. And does it need anything else? It depends on how we want it to operate. Like, let's just say it's going to take the list of points and return back the new polyline. So we're saving out that animal. So it's going to take, we're just going to copy this code right here. So this list of points is just going to be this LOP spatial reference isn't required. Let's just use the same spatial reference. So if we don't say anything, it'll be in the same spatial reference. Something like that. And then we could say return polyline. Okay. So all this function does, it's a really simple function. It's just going to take the list of points, build a new array, and that's the only array that'll be in the polyline, and it'll return that polyline back to the user to be saved out. Okay. All right, saved out in the, we still have to set up our insert cursor. We don't have an insert cursor, but let's get this polyline back. We'll say something like animal path is equal to, probably shouldn't call it save animal if I'm not going to actually save the animal in that step. But. So the animal path, it's going to be that. And then we need to write, I'll call this get current animal path as polyline. Okay, then save it using insert cursor. All right. I'm going to see if this runs, although it's not going to do anything yet because I'm not saving it as the insert cursor. Oh, one other thing I need to do is actually add the points as they come into the current points list. So that's right here. Anybody remember how to add points to a list? How to add anything to a list? Yep. Append, and then we put the row 2. Okay. All right. For fun, when at the save, I'm going to print the current points, just to make sure it's going to work. So we could get rid of that function. I mean that print statement once we're actually happy with it. All right. Let's see how this works. The locker is not defined. Okay. So it did that at the last. It did that actually right when we should have fed it to it. Okay, so I made a mistake, right? LOP is what we're feeding it. That's a local variable in this function. We need to feed it the global variable here. What do we call it? What do we call it outside the function? This list of points. The current points, exactly. So we need to feed it this current points. So we're just calling it list of points inside of the function because it's a general term. But inside the function, calling that something else. I'm also going to get rid of this print statement right here. I don't want that because it'll be distracting. Let me run it one more time. I see that there's an error. Array, add input, not point or array object. Those are definitely points, right? We gave it 2, 0, 1, 2. That was the point. I think didn't we have the same issue last week where yeah, but I thought I fixed that. Let's just shape at right there. Because this is creating a point. That's a point. Oh, but it's a point geometry. That was the thing. That was the issue we had last week. Was the difference between a point and a point geometry. Current point, row 2. Yeah. Just a second here. I know that right now I'm just giving it nothing, like a point that already exists. I mean, just the same point over and over and over again. But I'm going to see if this solves the problem. And then just build the point manually, which is exactly what we did last week. Okay. So that does seem to have worked. Did it finish? That does seem to have worked. So I think the way to do this is to just go row. Remember last week I was trying to figure out how to get it. Is it dot big X or dot little x? It's just a tuple. Oh yeah, because it just wants the. Yeah. Okay. That worked. Took a little while to experiment with what I wanted, but this is now it's getting the x and the y. I think it's big X. If we'd asked for just the shape, but not the shape xy, then we would have had to say dot big X. But because we asked for the tuple, the xy tuple, we had to ask for 0 and 1 down here. Okay. All right. So the point is that it appears to be working. These are the list of points. Okay. What's it printing right here? Current points. I'm also going to have it print the yeah.
When you look at the output, how are you going to know which animal that the lines correspond to?
That's why I just put this row 1 here. But that's a good point. So now we have it printed. The problem is that, look, I've printed 2, 2, 3, 4, 5, 6, 8, and 9. I think those are all the... Yeah. But the problem is what's actually printing along with the current points is the is the row that it's on, not necessarily the so if the animal doesn't equal the row, we don't actually ever change iAnimal. That's another thing that we need to do right here, is say each time through the loop, we need to set iAnimal equal to row 1. So now iAnimal will always be changing, and only if iAnimal is different than the very last animal will there be a new animal. So now this should run, and look at all these. There was only one item in each list, but now when we do it, there'll be multiple items in each list. So this is 2, 3, 4, 5, 6, 8, and 9. There's no 7, I don't think. Is there no 7? 1, 2, no, there's no 7. Okay. All right, but there is a problem here. Everybody recognize the problem? What's the first animal that we see here? 2. Are these points actually for animal 2 or are they for the first animal? They are. That's exactly right. Now, it only goes to 9, so where are the points for the last animal? Well, if we look at our loop, sorry, what were we going to say? If we look at our loop, the last animal is 9. So we never get to this code for the last animal because it never happens. So we do need to do that. We basically need to repeat these 2 lines once outside. Oops. Dedent, format, dedent, dedent, dedent. Control something. So now if we run it, the problem is that it's now row 1's probably going to freak out because we're outside the loop, so the cursor doesn't exist anymore. Okay, so it kept the value, but now both of these are 9. So we need to find a way to get the previous animal out. Okay? And there's actually a really easy way to do it, because remember, we don't change the animal till down here. So instead of row 1, what can we put there that would be the right animal that represented these points? What's that? This one right here represents the current row. But all these points that we've been compiling are actually from the previous animal. And we're saving that number out somewhere. I_animal here always represents the previous animal until here. We're not reassigning that value out till right here. So we can just change this to I_animal. And actually change this to I_animal now. And now every time through that loop, when we print, we'll get the right animal with its points. See how when this runs, we'll get, so these are 9's points, these are 8 points, these are 6's points, 5, 4, 3, 2, and now we'll have 1's with 1. Okay. I'm going to put it back on here just for a second there, and you guys can, in fact, let me see if I can get GitHub. This is where I'm going to leave it, by the way. So we haven't yet done the insert cursor, but all you have to do now is to save that out. I don't like how GitHub does not let me get to the bottom. So I can't actually save this on GitHub yet. So I'll leave that up there for a second. But what do we need to do to finish this? Well, you need to have a line in your code that's really similar to this, except for it's going to create an insert cursor, and you're going to give it the shape at, but you're also going to give it the animal. The animal has to be on the row as well. Okay? So you need the shape, comma, animal. And even before that, you need to create a new file called tracks or paths or something like that. And your tracks or paths, you should use as a template the GPS points. What do I mean by that? When you go to create it, use the create shapefile tool and use this path right here, your points, use that as the output tracks. I mean, use that as the template for the output tracks. And then you can create that search cursor, the insert cursor. You'll be creating that insert cursor up here, outside of the loop. The insert cursor, in fact, I can put it right here. Create insert cursor up here. And then you're going to save you're yours is going to look like this, except for it's going to say cursor dot insert row, and you're going to enter the, it's going to be called animal path. So you're going to feed it animal path where it says polyline, but then you're also going to have a comma, and it's going to be the animal. So it's going to look kind of like this. In fact, we'll save that in there too. Yours is going to look like that, assuming that your insert cursor looks like this. Okay. And that assumes that you create a feature class with the right fields, and let's call this FC2 actually. We can't call this cursor. Well, no, we can't. No, we can't call it cursor because it's down here. So let's actually call this, we'll call it a path cursor, and change this to path cursor. Because we can't call two variables cursor, and we can't call two variables FC. So I'll call this FC path to FC path equals so that's the what you need to add. Okay. So you need to create a new feature class in a path and add an animal field to it. Well, actually, you won't need to put it if you use this path as the template. You won't need to add an animal field because it puts the same fields on there. Okay. Use it as a template. All right. So that's good. I'll upload this at the end of the lecture rather than right now because it won't work. It did not appear to be working. Okay. So I'm going to do this. I'm just going to put a break in the video right here because this was really the lab